So for today, we are going to cover two topics. One is correlation and one is regression. We want to see about correlation. When we are talking about correlation, we actually would like to investigate the relationship that exists between two continuous variables. So for example, we want to see if our food intake is correlated with the calorie intake. Of course, it's correlated, right? But we wanted to know the strength of the correlation. Okay, so that's why we have this one of the statistical technique where we can analyze the R or the strength of the correlation. So the strength is being quantified as the degree of which two random variables are related, provided if the correlation is linear. Okay, so normally when one's get correlation data that they wanted to see the correlation, the first thing that normally we do, we plot the two-way scatter plot, because from the plot we are able to see a pattern. So at least we are able to try to visualize one straight line then that correlate the two data. A parametric test, we're using the Pearson correlation coefficient. So using the xi yi means like when you have two set of data, right? Data x and data y, and for example you have 30 data x and 30 data y. So each x data 1, y data 1, x data 2 and y data 2 and so on. From using this value we can calculate the Pearson correlation. So this Pearson correlation is actually quantify the strength of the linear relationship between the outcomes of x and y. So this is the equation. Later you can see the equation. Okay, we thought that as of average of the product of standard normal deviation of x and y, so the estimator of the population is known as the Pearson correlation of coefficient. So it's denoted by the R value. You can see here R is actually equal to the summation from data 1 to data 30. For example, if we have 30 data, right? And each data minus the mean for each data in data X minus the mean of X data, the mean of X, and each data Y minus the mean of data Y. Okay, and square root divide by the square root of the value itself. Okay, so we can find the R value. So the correlation coefficient is a dimensionless number, so it doesn't have dimension. So the maximum value of R can achieve 1, and we can go to -1 where we can say a negative correlation. So for any given set of observation, you should be able to find the R value of -1 to 1. Okay, so whether this value will determine whether you have an exact linear relationship between the X and Y. Alright, so if Y increase as X increase, so means logically your R value will be more than 0, and it's said positively correlated. If the Y decrease and X decrease, means like the R value normally will be less than 0. It's going to be a negative value, so we call it a negatively correlated. Okay, if R is 0 or towards 0, means we can say that there is no linear relationship between the two data set. Okay, and the variables are uncorrelated. However, a non-linear relationship may exist. So we can have other non-linear relationship, which is you can see a quadratic, or this one is R0, so no relationship between Y and X, right? So this can be a quadratic relationship, but you cannot use Pearson correlation. This is a positive relationship between Y and X, so you can see one straight line, and this is a negative correlation between Y and X. You can see the one straight line also, but is versus the positive line. Okay, so obviously in all of this testing you have perform the hypothesis testing. Okay, so we want to see whether the correlation is significant or not significant. What we interested in is the null hypothesis, either the row, which is the Pearson correlation is 0, or versus the alternative hypothesis, the Pearson correlation is not equal to 0. Okay, so before, we need to find the probability of obtaining the sample correlation coefficient. So the appropriate test statistic is, of course, we use T. So when we, the first step in this correlation, when we do a correlation example, you are going to have to calculate the R. Okay, calculate the R. Then you have to calculate the test statistic of T equal to the absolute value of R. N is the number of sample minus 2. So after you calculate the R value, you can calculate the T value. Then you will have to compare with the T value in the table. Alright. If of course same goes here. If is less than the null hypothesis. If it's okay. Alright. I don't know what happened. The internet, something wrong with that. Okay. Alright. So, but the limitation of coefficient of correlation is the R is only quantifies the strength of the linear relationship. It doesn't say like whether one is predicting the others. And the R is very high sensitive to the extreme value. For example, you have that one straight line, right? Suddenly you have one value that is a bit far from the mean. But the R will still using that value. When we calculate R, we still have to use the value. Okay. And using correlation, we should never be extrapolate the line, because we can only extrapolate the line if we are using the regression, because we are not predicting. Okay, the high correlation is not imply a cause and effect. For the cause and effect, we are going to look at the regression analysis. So we also have the non-parametric types of correlation, which is the Spearman's rank correlation coefficient. So this is, of course, if you cannot assume the data is normally distributed, you can use the Spearman's rank correlation. Okay. So it same goes there. Instead of using the Pearson correlation, instead of using the actual value, we are going to rank it. And then you are going to use the mean rank and so on. Same goes to the previous non-parametric test. Okay, so like this, the Spearman, instead of using the actual, for example, the X, the data 1 value, you are going to use the rank of that particular data and the mean of the rank. Okay, so the equations look similar, but the value itself is actually the rank and the mean of the rank. Where X and Y are the ranks associated with the ith, means the number of subject rather than the actual observation. So to make it, apologize for that. I don't know what happened. I'm using internet and yet it has problem. Let me try to connect to the Wi-Fi instead. Okay, the internet should be okay. All right. So the Spearman. So you are still going to get the R value for the Spearman. Okay. And when DI is the differences between the rank of X and Y. Okay, similar to the Pearson correlation, the Spearman R value will be more or equal -1 or less than equal or equal to 1. Okay, and so on. If it's 0, it implies lack of linear association between the two variables. Okay, so for if the sample size n is not too small, more than 10, we can test the null hypothesis using the same procedure as we're using the Pearson. So we can use the T, again the T test, but we are using the Spearman rank value, R value. Okay, not the actual value. Means like you have to use the rank in order for you to calculate the Spearman correlation. Like other non-parametric methods, Spearman's rank it has advantage and disadvantage. It much less sensitive to extreme value rather than Pearson. So if you have like extreme value, because you are only using the rank, so it's not going to affect that much. So in addition, it can be used when one or both of the variables are ordinal. However, since it relies on rank rather than actual observation, it does not use everything that is known about a distribution. So it does not really represent it, but you can see whether it's the two data are correlated or not. Okay, so next will be regression. So like I said, when we are talking about correlation, you cannot determine or predict the value. So it's not about x predicting y. You can only see the relationship between the two values. So we have two types of regression. We have linear regression and logistic regression. So the simple linear regression is like a correlation analysis. Is a technique to investigate the nature of the relationship between two continuous random variables. So the primary difference between these two analytical methods is regression enables us to investigate the change in one variable called the response, which corresponds to a given change in the others, known as the explanatory variable. The ultimate objective of this is we want to predict or estimate the value of the response that is associated with a fixed value of the variable. So we consider the model y equal to alpha plus beta x plus error. So E is error. Okay. So the variation of error is the distance of a particular outcome y lies from the population regression line. We'll see the regression line later on. Okay, so we call it a simple linear regression. So means like if the error is positive, then y is greater than the predicted y value. If the error is negative, then y is less than the predicted y value. Okay, so the parameters. So the parameter alpha and beta are constant, called the coefficient of the equation. So alpha is the intercept at y, which respond the value y when x is equal to 0. Beta is the slope. Macam y equal to mx plus c lah. Okay. If beta is positive, the value of y increase the value of predicted y increase as x increase, and the value of beta is negative, the value of like predicted y decrease as x increase. So in the simple linear regression, the coefficient of population are estimated using a random sample of observation. So before we attempt to fit such a line, we make a few assumptions. For a specific value of x, the distribution of the y is normal. Okay, so this linear regression we use when the data is normally distributed. So the specific value of x, the standard deviation does not change, and the outcomes y are independent from the x, yes. So we are using the method of least square. So we are going to have a look at this example of 100 low birth weight infants born in Boston. The data point themselves vary widely, but the overall pattern suggests that the head circumference tends to increase as the gestational age increase. Okay. From here, can you see the blue dot is the actual data. Okay. The blue dot is the actual data. What means when the baby in the growing bigger, means like the baby aging towards the 36 week, we can say that the head circumference also will get larger. Okay, so what now we want to see what is the factor or the value that can predict the head circumference based on the age. Okay, so this is the blue line. The blue dot is the actual data, but what we are trying to do, we're trying to fit a nice linear line between among the data, right? So we want to try to fit one line, either the pink line or the chocolate line. So we want to see which line are better. Okay, so the best line should be with the less error, which is most of the blue dotted data, which is the actual data, relies on the line, right? Or not that far. Let's see another. So this is the best line that we can get. where most of the data kind of lies on the line itself, right? So from the line, this is the xy. X doesn't change. Okay, x doesn't change. Y, we have the actual y and we have the predicted y. So see what are the differences between the predicted y and the actual y, where you can see there's an error. So the further the actual data from the line, the bigger the error. Okay, so what in this least squared method, we find all this error. So you have to calculate all this error from each dotted line, the blue dot, to the red line. Find the error and make a summation. So if this error is more towards 0, means we can say that most of the line, most of the dot, the blue dot is near to the line, not too far from the red line. So in this case, we can have a say that the r squared is 0.6909. So this is the interception, okay, and this is the beta, the slope, right? So then you can get the regression value of 0.6095. Okay, this is the slope value of x. So we estimate the coefficient of a population regression line using a single sample of measurement. So we draw an arbitrary line through the scatter plot, and two such line, we can see the brown and the pink one. So we can see, that's why I'm saying what we want to look at is the line that produce the least error that from the actual data to the line. So the ideal solution means the blue dotted or on the line means like error is 0, but it's unlikely lah, right? So because when we're using an actual data, real sample data, we want to try to fit the best straight line that minimize the error, means minimize the deviation of the actual y value to the y hat, the y that on the line. So the process of fitting a regression is represented by, this is the y hat, the y on the line, the red line, remember. So this is the estimated, the y-intercept, and this is the estimated slope for x. So we have to find this coefficient value. If y is the observed outcome of the y particular x and y hat is the corresponding point on the fitted line. So the error is, when we have the error, how we calculate the error, the actual value of y will be minus the y value on the line. So it's equivalent to actual value of y minus the predicted intercept plus predicted slope times xi. Okay, so the error is, we call the residual. If all the residuals are equal to 0, it is the ideal situation where we talked about earlier. So where all the point lies directly on the fitted line. So however, it's not in the case in the reality. So different criteria of goodness of fit lead to different function of error. So one of the method we call is the sum of squared error. So this is the sum of squared error, or the residual sum of error. So we wanted to minimize the summation of this error. So imagine you have to calculate each of the error that the deviation of the from the actual y to the y on the line, and then you have to square it and make a summation. Then you can find the SSE. So this is all the equation. So at the end, what we are going to get, the beta value, or the how you can calculate the estimated slope. So this is the summation to calculate the estimated slope. I'm going to stop for a while. Then after this we are going to then I'm going to stop for a while for 5 minutes. Is it okay? Kita stop kejap kan?
Okay.
Alright. Before we continue, sekejap. Okay, let's continue. So once we know the estimated alpha and estimated beta, we are able to substitute these various values into x into the equation for having the line. Solve the corresponding values of y and plot these points to draw the least square line. So in the inference for this regression coefficient, we like to be able to use the least square regression line to make inference about the population regression line. So before we continue on making the inference for regression coefficient, we need to understand the property of the regression coefficient. If the error of y means alpha plus beta xi, the variance equal to the standard deviation of y over x, and the covariance for xy and x hat actually like is equal to 0, so then the least estimator has the following properties. Okay, so this is actually for us later on to test the hypothesis testing. So the E for the beta, the estimated slope is equal to the slope, and the variance is equal to this equation. And so the E for the estimated alpha is equal to alpha, and the variance, you can use this equation. So don't worry, I'm not going to ask you to memorize any equation. You can always check when you need. Okay. So this is the most important one. We want to see the Bayesian or the standard deviation from the regression. So this is how you calculate, where you previously you can calculate the SSE, right? So and you be divide by n minus 2. So it's actually like the summation of y is the summation of the error squared divided by the n minus 2. Okay, so this is the most important value that you want to calculate, because we are going to use the value to test the hypothesis. Okay, so the slope is usually the more important coefficient in the linear regression equation, because beta quantify the average change in y that corresponds to each one unit change in x. If we are interested in conducting a two-side test that the population slope is equal to beta naught, which is equal to 0, so our null hypothesis is either the slope is 0, or the null hypothesis that the slope is not 0. Okay, so there is no linear relationship between x and y. It can be shown that if beta is 0, is mathematically equivalent. In fact, the way that when we calculate the remember we have this correlation coefficient last time, so we can use the xy and xx. Okay, let's see some example. Actually, it's much more easier. So let's go back to the example of the head circumference. So the least square line fitted on the 100 measurement of head circumference and the age of the baby in the okay, so the y hat, this is the estimated alpha, and this is the estimated slope. Using that, you can because this is the error that you calculate from the actual y value to the y hat. So the y-intercept of the fitted line is 3.9142. Theoretically, this is the mean value of head circumference at the baby of age 0. But however, age of 0 weeks does not make sense. So the slope in the line is implying 0.78, implying that every week, every 1 week increase in the baby age, the head of the infants will increase by 0.78 centimeter on average. Okay, that's what it means by having the line. So you can now estimate. So let's say I ask you to estimate the head circumference of the baby when he or she at 38 weeks. So you can use the equation, just put it in the y equal to 3.9142 plus 0.7801. You just put that 38 here, then you can find the y, which is the head circumference of the baby, to estimate. Okay, in addition, we can calculate the SSE. Remember the standard the error. So we can have the 1.59 value, and the variation of B is and this is the value for the variation of B and the variation of the intercept. So then we can, what interest is we wanted to conduct a two-side test, which is beta equal to 0 or beta is not equal to 0. So the test statistic, we can use the t-test. Just you put in all the value. The beta hat, beta 0 is 0, because remember the null hypothesis is beta equal to beta naught. So the beta naught is 0 here. So you can have the t value, and of course from the t value you can compare with the one from the table. So since we can we can find the t value from the table. If you are using from 0.001, we can reject the null hypothesis. So then you can also like calculate the confidence interval for the beta. Okay, so if, okay, another one, that one is a linear regression, but if your data cannot be assumed normally distributed, you can always use logistic regression, or logistic regression can be used if your outcome of the y is 0 or 1, means like is not a scalar value, not a continuous value, you can, it's a categorical value, so you can use the logistic regression. So for simple logistic regression, so if we are using only one x, means one value of x. Actually, when you're talking about regression, you can have more value of x. Okay, so this is where we are talking about the probability. It must be the range of 0 and 1, and the term of alpha and beta in contrast could easily yield the value that lies outside this range. Okay, but the difference between the logistic regression, you are going to log the value, means instead of using the actual value itself like the linear regression, we're going to use the log instead. So to accommodate this problem, we fit the model in the form of the probability equal to the error the log between the intercept and the slope. Okay, this is like a usual one, right? Alpha plus beta x. It's just like now you are going to log the value. Then it's going to look like this if you plot the value, because it's only like 0 and 1. So the y is only 0 and 1. Okay, and the odds in favor of success is the probability divided by 1 minus probability. Then you can go for the logic ln. Then after you log, then you are going to get the alpha and beta. Don't worry, this is only for information, no exam question about this. So therefore, the modeling of the probability P with a logistic function is equivalent to fitting a linear regression in which the response is the algorithm of the odds of success for a dichotomous random variable. So we assume that the relationship of the logit P and the ln P is x and linear. So the fitted equation should look like this. The ln of the estimated probability divided by 1 minus the estimated probability equal to, actually this is similar to the linear regression. You can see that it's except that we are using the probability because we are using the log, so we want to see whether the probability of the value is more to 1 or 0, because when we are talking about logistic regression, we only have two values to predict, or 0 or 1, not the actual continuous value. As with a linear regression model, the estimated alpha and estimated slope are estimate of the population coefficient. However, we cannot apply the method of least squared, which assume that the response is continuous and normally distributed. So instead, we use the maximum likelihood estimation value. So the ordinary least squared seeks to minimize the sum of squared distance of the data point to the regression equation. So the MLE seeks to maximize the log likelihood, which reflects how likely it is that the observed value of the response may be predicted from the observed value of the explanatory variables. The closed form solution does not exist. So the estimation of the parameters must be obtained by an iterative procedure. So in order to estimate the probability P developing the outcome of the disease, for example, so we are going to use the ln of the estimated probability equal to estimated intercept and estimated slope. So for the given x, and take the anti-LT algorithm to find the estimated P. So our null hypothesis is similar. So beta is equal to 0, or the the alternative hypothesis beta not equal to 0. Okay. So, but in this case, we have to use the Z test instead of the T test. Okay. Okay, it does an overview for those two topics, for the correlation and the regression. But don't worry, for next week, okay, after by 24th, I'm going to give you the take-home exam, but not related to this correlation or regression. But in week 11, we are going to have like more example. We can do more example and exercise, so you can understand more. I know that because when just lecture, it's not that easy. That's it. Do you have any question? Oh, okay. So but how about, have you ever been to a clinic?
Yes.
So did the doctor perform a blood pressure measurement?
Yes.
So can you describe a bit about what are the data that normally like the doctors measure?
Systolic and diastolic pressure.
All right, good. All right. So how do you think this can help you in terms of the healthcare system?
So it can help. So we can know whether the level of our blood pressure is at normal or at high risk, I think.
All right. Thank you very much, Hakim. Okay. All right. So next, Augusta.
Yes, doctor.
What for example, according to this paper, there are a few analysis like stages that we need to do on the big data. So the first question is like, what do you think in your from your what you thought about what is big data actually? What is big data?
I think big data is something that we measure. I mean that we take from a patient, the measurement that we took from the patient, and I think the patient, each patient we took the measurements such as blood pressure, like all over the world like that.
Yes and no, because that's a part of big data. That's what is called the physiological measurement data. Yes, when we have like a lot of data coming from all over the world, it's becoming massive and it can be a part of the big data. But big data also means that you are combining data from a lot of different sources. So, for example, you have the physiological measurement, you can also have their social media data, you can also have the weather data, you can have a lot of like they are combining a lot of data, so that's why it's called a big data. So it's not only coming from only one sources of data. Okay, so another question to you, Augusta. So for example, in the descriptive analytics, saying here, once someone like when someone like collecting all this data, we can use a descriptive statistics to present or visualize the data. If you are asked to perform a descriptive statistics, what type of like a graph or visualization that you think will be beneficial, and any other analysis that you would like to do, Augusta?
I think for descriptive analytics, I think we can either use histogram or chart if we want to compare the height or weight between different patients. And I think if you want to know if the patient have a certain disease or what, you can use diagnostic analytics.
Okay, that's good. That's good. Okay, so so make sure later on when you are in your final year, maybe when you are, or even in your doing your labs, so make sure you also do this charting, yeah, histogram or chart or anything that you think very useful. Okay. All right, next, Amiza. Thank you, Augusta. Amiza,
To doctor.
kalau if you can see here under the diagnostic analysis, it aims to explain a certain events occurred. I think this is very similar to what you've learned in statistics. So can you tell me some of the technique that we can use for diagnostic analysis?
Is it like t-test, ANOVA?
Yes, but before that, before you actually learn about t-test and ANOVA, about events, about probability, start with letter B.
Binomial?
Binomial boleh satu. Got another one?
Bayes theorem.
Yes. Bayes theorem. Kan Bayes theorem is dealing with probability kan? So that's the usage of those things. Okay, so I know that you have learned this. Don't worry, I know that you might not remember the formula or the name, but at least when you are dealing like handling this type of data, you know the steps. So at least you know, oh, I've heard about this, and you can later on these are the techniques that you can use under the diagnostic analysis. All right. Okay, thank you, Amiza. Faza, are you in? Okay, so under the predictive analytics, so it say like it reflects the ability to predict future events. Okay, so can you think of any statistical method you can do a prediction? this regression, linear regression, like I think is, or maybe you didn't attend the class, because I attended the class for the first group one, and then you guys have a holiday on that week. Okay, never mind. But we have this linear regression and logistic regression. So this technique can be used to predict the future events. Okay, so you can plot a certain event that you wanted to predict, and then you can see the trends and maybe determine the probabilities of the uncertain outcomes. So for the logistic regression, yes, it's you still using the probabilities, and the linear regression is using the predicted point and um, the linear line that you are going to create. But it's okay. Next week we are going to do some tutorial on this regression and also the correlation. Okay. Another question kan Faza kan. So for example, during this situation, what are the things that you would like to predict?
Mostly to predict how the trends for COVID-19 cases, right? How it be in the future.
Okay, that's good. Yeah, actually, like we have to predict what will be the future, because it seems like uh the trends are not unpredictable. Kejap turun, kejap naik kan. So it will be a good idea if you can do some prediction. Okay. So not only statistical analysis, you can also use machine learnings if like a non-linear prediction. So for future prediction. Okay, thank you Faza. So do we have use one? Okay, dah hilang. Alright, never mind. I have another names. Nadarul.
Ya, saya rata
Nampak tak the figure 1 yang saya share ni? Are you able to see that?
nampak.
Can you just from what you understand from the figure, can you like share with us your thought about the figure?
So for the first descriptive analytics, more to the what happened, like why this event happened, and then for the diagnostic analytics is why the event happened, and predictive is what are the outcomes of the event, and then the prescriptive analytic, what to make it happen. I cannot understand it, whether we can make it happen or else.
So for example kan, I think the descriptive analysis is what is happening, right? So you are given a bunch of data, a lot of data kan, macam tiba-tiba je I'm going to give you example. So what be happening now in COVID-19 kan, suddenly like too many people attended the clinics with same symptoms. So people want to know what is happening, so they will describe the condition. So they will plot histogram or graph. So how many people, maybe like from 100 people, how many attended with flu and sore throat and so on. So they can see there's they understand what happened. So then it go for the diagnostic lah. So why people, like when attending the clinic, so many people having sore throat, then they go for diagnostic, they go find the cause why it's happening. And then from the data that currently we have, now we have like about 125,000 kan. So that's why the one that remember, if you always see this Datuk Nur Hisham always talking about the R naught, he's actually like predicting the situation in the future based on the R naught number. Actually R naught is a statistical analysis tools. So it's actually like we want to see the regression or the what will happen in the coming few days, months and weeks. Okay. And then the prescriptive analytic is actually like for the vaccine. Okay, now I'm giving you a very good example. So make it happen. So in order for us to stop a certain thing, or in order for us to alter the outcome on what happening, so we said that maybe we need a vaccine. So we prescribing quite of how many percent of Malaysian population later on will have the vaccine. Okay, so this is the solution we are trying to solve, and we are trying to predict what will happen in the future, and this is what we are trying to make intended positive outcome to make what make the future to make it what we want it to happen. Okay. So we have Adrian Yasmin.
Yes, Doctor.
Have a look at the characteristic of the big data and try to explain on what you understand from it. Yes, what does it mean by big data? What is actually the characteristic of big data?
We have a lot of data from, and this is what I understand. Macam we have data from a lot of sources, and then they under different formats, such as we have heart blood pressure, systolic, diastolic, and then we maybe can find the relationship.
So like, let's say, I think you can see from the paper. So one is like large data sets that combine the few characteristics, which is high amount of data, of course, like what Augusta has mentioned, that maybe it coming from maybe the whole world giving you the blood pressure data. Wow, that's big. Okay. So and it's being generated as very rapid. Maybe some of the data are social media data. Is also like can be used to help with the healthcare now. And I think whether it's coming from a very trustable sources. So not all data from social media can be trusted. So maybe you have to have a filter later. So of course, the characteristic of big data is too variable. The variation is big. So because of course it's coming from the flow rates, and so means you may need some prior analysis to start off like cleaning or filter the data later on before you can use all of it. So because it's coming from a lot of it's big volume, right? Okay, so you can see here in our context, high volumes of data. So is a lot of multiple medical sources. So biomedical images, can you give me some example of biomedical images?
Yeah, biomedical images, X-ray, CT scan,
Okay, good. How about lab tests?
blood type.
Okay, good. Thank you. So before I go and call someone else, okay. So the processing of big data, it can be performed in two methods lah, two manners lah. One is batch processing and the stream processing. Okay. So batch processing is something that we collect data for a certain period of time. So then we do proper analysis and give the outcome of it. But for the stream processing, is something that it has to be rapid. It has to be like macam Google Analytics kan sekarang kan, if you type like certain keyword in the Google, so it give you a certain suggestion. That's something a real time. It has to be a stream processing. Okay. So but in our case, for this is all the software that's available for the big data processing frameworks. It's okay, that's not our job, but at least we have to understand what is the for the healthcare system. Yeah. All right. So let me call Yirong. Yirong, are you there?
Yes, doctor.
Thank you. Okay, if you can go to this, to this figure 2. All right. So, what do you think about the visualization layer? So, maybe you can give a thought like what can any statistical method that can be used in the visualization layer?
Maybe using like we learned before is the like analysis, like what will happen, something like that. Because I haven't read until here.
That's okay. I just want to know your thought before you. Okay, so actually visualization layer is something that being shown to the patient, okay, or to the user. It's not like us, like we are at the back end. We are the, for example, like a computer is the screen. So if you see the search engine, the Google, you can just see the one box that you can enter the keywords that you want to search, right? So that's the visualization layer. So imagine like for the healthcare, normally what you would like to see. For example, if you attend a clinic and they give you a certain, then you can use an apps to see what you want to see about your health.
Maybe for me, I will see about my cholesterol level,
Yes.
or the blood pressure,
Yes.
or the concentration of sugar in my blood.
Yeah, you're right. So it's about how the data being presented to you, right? So it has to be, maybe you can see in a table manners, You can also like have a graph. For example, if you measuring your cholesterol monthly, so you can see a graph, right? So this month, next month, and even the glucose value and even the blood pressure value. So that's a visualization methods. Okay, so it's more like the description part, the histogram, the graph, and so on. Okay, that's on the visualization. All right, so
Thank you, doctor.
I need to go and find someone else also. Thank you. So who else? Oma, are you in? Okay, never mind. Shannon, are you in?
Yes, Doctor, I am here.
Hi. Thank you, Shannon. All right, Shannon, can you, what do you understand with the data layer for the figure 2?
So that's the bottom layer, right? The last one.
Yes, correct.
So I think those the sources we get the data from. So if you can see there like EHR, social media, body sensors. So that's where all the data is being collected from. That's then going into the big data. So I think EHR has to do with the hospital. So the data that they get from the hospitals that they then input. Social media, I'm not too sure how people put their their details on social media like heart rate, etc. But body sensors, so things like our smartwatches, etc. And then mobile phones, some of the health apps that we have that collect all this data.
Yes. So, you are in your second year too, yeah?
Third.
Oh, yeah, third year. That's good. So, when talking about body sensors, have you ever seen any sensors in our department? Like, have you used any sensors?
Yes, we've used some of the heart rate sensors, some of the ECG and EKG machines.
That's good.
For some of the labs. Yeah.
All right, that's good. So those are giving data, right? So those data are will go into the data layer. All right, thank you. Priyanka, are you in? What you think about the data storage layer?
How we like tabulate the data or interpret the data like that. I'm not sure what this. I'm confused.
All right, so the data storage layer is where we store the data. It's actually like about storing lah. It's like a storage. So when you have a lot of like input from the data layer, you need to have a place to store the data, right? So this one that's why people are using the cloud or the hardware or anything. But now people are talking about cloud. So most of the data are being stored at the cloud. So they are using databases. Okay, that's a different story. That's long. That's another subject if you want to learn. But yes, before you can perform any analysis, you have to store the data. So it be safe and especially in healthcare data, right? Oh malah, never mind lah. Zuhair, have you ever heard about the electronic healthcare records?
No.
Okay, so have you ever been to a hospital?
Yes, doctor.
Yes. So when you went to the hospital, do you have to register?
Yes.
That's the electronic healthcare records lah. So when at the point of you have to register, then you can see the doctors, then you go to the lab test and everything. All those data are being stored in something called the electronic healthcare records. Before this, they only write into a paper, but now they make everything like electronics. So it's being stored in the system. Okay, so can you give me examples of data can be available in the electronic healthcare records?
History of patient, results of blood pressure, heart rate.
Since you're saying that, a lot of like example of blood pressure. If I want to know whether you have progressing, once, for example, like a group of patient entered the hospital on day 1, and when they discharge, the same group of patient discharge. So if I want to see any differences, what type of test that I should use?
Like ANOVA?
Yes, but now I'm looking at a same group of patient before they enter the ward and after they discharge the ward.
The T-test.
Yes, it's PET. Bukan 2 test tau sebab sama kan? It's a
Oh,
sample of patients, so it's a paired t-test before and after kan.
yes, yes.
Yes. Alright, thank you. Amma ada Amma. So under the 4.1.2, the big data has to be prepared before it can be processed statistically kan. So what do you think you can use any techniques of data cleaning and data filtering? What I want you to think is, what are the things that you've learned in your lecture that can be used for filtering and cleaning? That's a reward. So whatever techniques that you have learned in the lectures that can be used for filtering and cleaning.
For cleaning, maybe when you use the body sensor, there is like if you use like electric signal, there will be noise. So you can use a circuit to filter out the noise.
Okay. How about any statistical method?
Statistical methods. In SPSS, we can fill in missing values using certain function that fills the missing value with the means.
Okay. All right. That's good. All right. How about confidence interval? Can we use the confidence interval to do some filtering? Okay. So for example, now when you use the confidence interval, you can select the data that are within 99% or 95%, kan?
Yeah.
So the data that are not within the normal curve on the right or the left side, it might be a data that can be assumed not belong into that population. Am I right?
Okay. Yes.
Kan. So we can use that method lah. So we can say that the data are being excluded from the analysis because the data are outside the interval that you are looking at, right? So that's one of the example of the confidence interval analysis that you can use lah. Alright, thank you Ammar. Dua Hakim, betul. Hakim. Right. So dekat feature extraction and feature selection, give me some example of statistical method that you can use to extract or select features.
How about ANOVA, Doctor?
Okay. Go through with it. Bagi tahu saya how you want to use ANOVA.
We determine whether to reject or not to reject, fail to reject.
Okay, that makes sense juga. Cuba bagi saya satu senario. Can you think about a scenario that you can use ANOVA? So, untuk feature extraction and feature selection. So, for example, you are looking at 3 groups of patient ke? Macam tu lah. Give example macam tu.
The effectiveness of a group using antibiotics.
Bagus. That's very good example. Okay, teruskan. Okay, that's a very good example. So, for example, if you have like 3 groups, one group is using the gold standard or the antibiotic that has been proven by the KKM, for example, kan? So, you have another 2 groups with a newly antibiotics. Okay, antibiotic B and C, the one you just bought at the hospital. So, if you can, your hypothesis should be the same, right? So all 3 antibiotics should be giving you the same results for the patient, but suddenly cannot. You have to reject and say that one of the new antibiotic giving you a different result. Yes, so that's a good example that you can say that that's how you are selecting or extracting those data. Okay, that can be used. That's as another example. Okay, and also the feature selection ni we can also use simple linear regression or logistic regression or correlation. Okay, it's okay. We are going to cover the tutorial next week for these 3. But at least you have the idea on what are the usage of these methods. Okay? Thank you. Yazid.
Yes, Doctor.
Good. Macam mana about the predictive model design? Can you think about some model ataupun statistical tools that you can use to do a predictive model?
Neural network.
Oh, wow. Betul.
Or
Dah belajar ke neural network?
No.
Betul lah, betul. What you saying is so right. Neural network lagi?
Regression, linear regression.
Ya, betul. Ada lagi, ada tak macam apakah software awak boleh gunakan? Kan dah belajar guna SPSS?
Oh, yeah.
You have been using SPSS, right? So you can use that to do the predictive model. Okay, thank you Yazid. At least ada neural network tu. Okay, pandai dah ni. Alright, okay. So all of you can see this figure, right? This figure 3, big data architecture ni. This is a very important figures. For example, if I ask you in your exam, so I need you to understand the figures, yeah. So these are the data layer that I think one of your friend already discussed tadi. So the data can come from various sources, from the electronic health record. It can also come from social media, body sensors, your mobile data, and also your lab tests, right? So all these are data, these are numbers. So it doesn't mean anything if you did not process the data. Okay, so all these data, okay, of course is going to be acquired by a certain devices. For example, for the ECG or the heart rate data, the heart rate signal is acquired by the ECG machine, right? So the data acquisition. So all this data after being acquired is going to be stored in the database. This is the data storage layer. So all the raw data are going to be stored in a database. So of course it's going to be sent to, okay, what is semantic module? Okay, you have your raw data. And this is a dictionary tau. Ontology like a dictionary is something that if I have a systolic data, the data is going to be labeled according to the international labeling method. So if I have a systolic data from Malaysia, if I have a same reference from overseas, so the reference may be number 13 and number 13, we know that is a systolic value. So it's a dictionary so we can use the data across the countries and everyone can understand what is the data. Okay, so then the data has to be normalized because like lot of data, a lot of variation. So normally it's going to be normalized for a certain range so it can be further processed. Okay, so it's going to be clean and filter for all the outliers and maybe a missing data and so on, like what your friend said. So we can use certain method to do a feature selection. Then from there, the significant features are going to be extracted and used for a model. Okay, so you can find the significant features. So you can have the model. You can store the model in the database also. So when new data came, so you can use the model that has been stored in the database. Okay, so you can also use the machine learning to do the predictive model, macam like your friend said about neural network and so on. Okay. So after you all the data that has been prepared also being stored in the database. Okay, and we have another one we call it stream analytics layer. So this is batch. Batch ni maksudnya it means like you don't have to give the results on the spot. It's not a real time results. So you can store your data, do the processing and so on. Then you can come out with the results. But about the stream is not many stream. Means like not many processes because you have to give the results as soon as possible, especially for the emergency results and so on. Okay, so then after you process everything in the big data processing layer, so you are going to visualize the data. You are going to give the prediction to the patient based on the dashboards, like your friend said. She wanted to see her glucose level, the cholesterol level and so on, and if there's any emergency button that she can push for if she have emergency, or is any indicator that you have to see the doctors. Okay, so these are the layers that you show to the patients or to the users. Alright, so if you are being asked to give some how data being managed in healthcare system, so you should understand this figure in order for you to redraw and at least according to what you're understanding. Okay, so alright, so we have one example. So this is emergency model. Let me see. Right. So okay, let's go through with this example. So this aim of this example of this prototype is aim to detect potential dangers of the patient. So it's choose to implement the module of emergency detection, figuring the visualization layer, and also the proposed architecture. Right. So these are all the things that are available. MongoDB lah is the database lah. Okay. The Spark streaming is the stream. Okay. You see here. Yeah. I want to show you one example. What are the analysis that they are? Okay. See here. The implementation of the proposed of the emergency cases. What is using here is a logistic regression. Logistic regression is a statistical method, right? Is using the logistic regression. So this is one of the statistical method that we'll do some tutorial next week. So by using the logistic regression, we can see the detection of the abnormal situation. So it can be stored in the database. So if anything, what happened with, you can have the real-time monitoring of the blood pressures. For example, the patient, the data will be the blood pressures data, and it's using the logistic statistic in order for predicting whether it's going to be normal or abnormal for the coming week. Okay, it's using the window approach. So see, this another visualization method. You can plot the patient's blood pressure value according to the days it's being taken. Okay. So the patient can see whether their blood pressure is varies across 1 week, 1 month, and so on. Okay, so these are the dashboard for the visualization layer. All right. So and these are some of the coding inside the processing layer. So it when you use SPSS at the back end, you can actually like see the code how it's being processed. Okay, the SPSS is making it easier for you to do statistical analysis. All right. Okay, so this is example. So I'm going to stop sharing for sharing. Okay, so do you have any question?
I have a question about the characteristic because I see that the journal say that if we have the high value of data, we will have smaller volume. May I know why is like that?
Okay, this is about the characteristic of the big data, right?
Yes. The sentence is the big data has a low value density, which means the raw data has a lower value compared to its high volume.
Oh yeah, the volume will be high. Means like it's going to be, this is you're talking about the big data refer to large data set, right?
Mm-hmm.
Okay, and the data come with different formats and finally veracity, which okay.
Below the sentence is big data has a low value density, which means that raw data has a low value compared to its high volume.
This is Oracle. Oracle is a type of database. Okay. So Oracle, okay. When they create when they know that they are dealing with big data, there's a lot of company outside there that actually like come up with the database how the methods of storing the data. Okay, you can see. Okay, and one of the type is Oracle. Oracle is a type of method of database. So for example, like it's going to give a key attributes of big data. So raw data has a value so for example, if you have if the volume is high, but you can, once you normalize it, you are going to see. So it's not necessary. Okay, like we said earlier in one of the statements saying that, okay, now we are talking about the social media data. Okay, I'm trying to figure out some examples so we can understand. So we are talking about the social media data. There's a very huge volume of it, right?
Yes,
but
yes.
only a certain part, only a certain important cluster that is can be used for analysis. So in Oracle is introducing, like, even though a lot of data go into the database, it's going to give it a key attributes to the data. Means like if it thinks that the data is only like not relevant, it's going to flag, or it's going to only flag the relevant data. So
Also, it means that we get the high volume of data, but we only use the important data only.
yes, that's correct. That's why if you can see in the figure 3, you can see that the data layer, it can take a lot of data from across of sources. So, but the important one, they will refer to electronic health record because it's a formal data, is the body sensors and the lab test. But the social media and mobile information data is going to be an assistance if they have a lacking of information. So it's about the prioritizing which type of data is more important than the others. Oh, that's very important in big data. If not, it's too much.
Okay.
All right, thank you for your
Okay, thank you,
question.
Director.
Yeah. How about others? Do you have any other question? If not, okay. So like I said, during the class, so one question will be about this. Okay, so you have to understand about the management of data, because what you're learning in statistical analysis is only the tools to perform a bigger roles. Okay, so the whole picture of like healthcare system is dealing with a lot of data, so you have to really be at least or you can try to use the statistical techniques when you are dealing with data. Okay, so what I'll do later after this class, I'm going to share with you in the group you for your selection. So next week we are going to have a smaller group like last time, because I wanted to do the tutorial for the correlation and also the linear regression, because those will be in your final exam as well. So please join one of the session. Like usual, I might be opening 5 slots, so you choose which slot that you comfortable and available. Okay. So have you got the value? You can type if it's too long. That's right. There's a long number. 329 something, right? 329 ... How about the summation of x squared? Do everyone get the same results as Amma? 66128. Yep. I think the correct one is 8616. So okay, Amma, later you just check. Okay. So you got the x616 ... Now we have all the components, so we can find the xx value. So we can have the xy lah. We find the xy first. So the summation of y, this one will be the 329 something, right? 329 ... minus. Okay, how about the sum of x? The sum of x and the sum of y. So you can have the sum of x times the sum of y. You divide by n. What will you get for the xy? The xy should be negative. Yes, you should get the negative 208 plus. Okay. How about the xxxx negative 208 ... How about xxxx? Okay, what is the xxxx? 42 something. This is for xxxx, is it? Nabila, do others get the value, the same value 4202 thingy? If we assume that Nabila's result is correct, but I think it should be a bit lower, but it's okay, you can check. But regardless, 42 blah blah, you can get the B1 value will be negative, right? So in this case, what will be the value of B1? Okay, let's say that if I got a different value of XXXX, that will be like let's say I get like about 2119 22310. I'm going to get my B1 value will be negative minus 0.098. Okay, something, right? So when we got the B1 value, you can calculate the B0 value will be, you got the mean of Y of 14775, right? Minus the 0.098 times with the 37426. So your B0 value will be about 18458 something, right? Okay. I'm talking to myself, but that's fine. So then, last but not least, you should be getting a um, equation of like this. Y will be minus equal to 18458 plus, oh, actually it's minus 0.098 of x. Okay. So last, what I'm going to look at is this equation of y. Okay. So of course the value will be different in your exam. So it should be smaller, means it's going to make you easier for you to do the calculation. But at the end of the day, I would like to see a equation like that, y equal to something something. All right, so you can see here the slope is negative, which is logical. The higher the odometer value, it's going to reduce the price, and the price of the car starting with 18,000 plus. Okay, so any question? Thank you, Nabila. At least ada orang jawab.
Okay.
I know. So this type of question is not about, it's not difficult. To be honest, it's not difficult, but you have to do to manage your work. So you have to do the table. So you have to calculate by yourself. It's like at least properly. So that's going to be make it tedious. Okay. So regression, correlation is not the difficulty of the question. It's about how you are going to perform your calculation. So if you get it a bit wrong, so then that is going to make you confused. Like what? Okay, so but don't worry. I think in the exam the numbers won't be that big. So it should be that this millions and billions thing. So it should be smaller lah. But you won't be getting the same numbers as your friend. So I'm not worried about you copying each other, because you are going to get a different numbers. So you have to do by your own. You have to know by your own, right? So got 3 questions lah. This one regression question, one correlation question, and the other question will be the last week, the one that we discussed. Okay. So that's going to be the last questions. So means about the architecture, about the one that we discussed last week. Okay. Any question about exam?
The exam will be only on your part or
Yeah.
Dr. Hamid?
Hamid will sorry, exam will be only on my part. Dr. Hamid I have done his part. His part is all the continuous assessment marks. Mine will be on the final summative assessment. So there will be only 3 questions in the exam. One correlation, one regression, and the other one is like the one that we discussed last week, the architecture about the big data and so on. Cuma like of course lah, I'm going to in the big question, maybe you have like some smaller question that you may need to answer, but the most the biggest chunk of marks will be on the correlation and the regression lah. Yeah.
Okay.
I know. I think you're supposed to be able to pass. It's just like you just have to do your right. Any other questions? If you have any question later on, you can just share with the WhatsApp group. So and we can discuss. I think because you have some time later, right, before your exam. But there will be no class next week because we are not allowed to do any class in week 14. Dah azan dah. Okay, if no, that's all for today. So thank you very much. You can go and check your calculation. Okay.
Okay, doctor. Thank you.
Alright,
Okay,
doctor.
thank you.
Thank you.
Thank you.
Thank you.
Thank you.